This, and the other learning resources in this course have been made possible by funding from the European Commission's Erasmus Plus program.
Cloud. Voila. So today is the last day of the module on laser scanning. So I hope that that so far that you liked the topics that have been discussed during the last few days. For today, I would like to cover the presentation of point clouds using online resources. So especially if you're already familiar with the last topic of the session on photogrammetry or image-based 3D modeling, where we dealt with online visualization and the use of JavaScript-based browser visualization. Today we will do something similar. So again, we will make our own local server. We will convert laser scan data, and we will use our browser to visualize point clouds. These point clouds can be extremely large. So if you go on site, or if you go to your museum, or if you make a model of your architectural plan, and the finality of that data processing is a point cloud, you can actually use the techniques that I'm going to show you today to visualize your point clouds. The problem that I experienced today was that given the fact that not everybody of you is using Windows, it means that there were some difficulties with converting the data. So especially for the Mac users, the first part of the demonstration will only be useful for you from a conceptual perspective, but not for a very practical perspective. However, I just also mentioned it, I've been able to work on a workaround in Mac. So at the end of my demonstration, I will switch my computer and do the same demonstration again, but then on my MacBook, because it's a little bit more tricky or difficult to work on it. First of all, of course, welcome. I forgot to welcome you to this last session. And another question: do you have any questions based on the previous presentations?
Not me.
Perfect. If you were not able to work on the daily exercises, as was already mentioned just a few minutes ago, but now it's also on in the record, so now it's official. If you were not able to work on the daily exercises during the specialist course, please don't worry too much. You will have some additional time also after the end of the summer school. The WhatsApp group will also stay open. So if there are any questions on that, I would love to assist you wherever possible. Also, email correspondence is of course an option. And as soon as the content has come back a little bit here in my private environment and my professional environment, I will definitely also have a look at the material that you already submitted. I made a start with it already a little bit, but I will continue that process, of course, that you can use that feedback also for further work. So let me share my screen. Voila. This is for me. This is also. So today we're gonna talk about the use of PO3 for point cloud visualization. Can you all see my screen again? Okay, perfect. So point clouds publishing point clouds using PO3, a very convenient way of publishing point clouds, and I'm going to show you how to do it, and I would like to encourage you to do it as well in the demonstration. It will also be a part of the general exercise that you will get at the end of this workshop in summer school. So like I said yesterday, most of the times the finality of your data acquisition and data processing after acquiring the data, registering the data, filtering the data, classifying the data, most of the times that's not the requested deliverable. So you will have like digital elevation models of architectural plans or any other things. But in some cases, point clouds are requested. And in that case, you actually have a few options. You can just say, okay, I have my LAS file, I have my E57 file, I put it somewhere on the internet and people can just download it. big disadvantage of that approach is that, of course, sending point clouds via the web is quite challenging. So if you do it via WeTransfer, you're only limited to a certain amount of data, especially when you just use it as an attachment for your email via your email server. But also WeTransfer is only limited in terms of data delivery, and also in the spread or the amount of people that you can reach with that. Because also point clouds can be very massive, so you will deal with gigabytes, or you can deal with gigabytes and gigabytes of data. And of course, it's not always very convenient to ask to people to install additional software, to install additional software, or to buy a license for a specialized package, or even Cloud Compare might not be very convenient for people if they are not familiar with these types of software. So in that case, it's very straightforward to use some kind of a browser-based environment where people can just type in the URL, access the point cloud, do measurements, do point cloud interpretations, and stuff like that. And that's actually the objective of today. So there are multiple approaches or multiple solutions developed for this challenge. So we're talking now about online visualization of point clouds. There are some commercial solutions like Leica TrueView. If you buy a Leica Cyclone license, you also have a free license of TrueView. And actually, if you have prepared your data in the Leica software, you can export your data and make it visible using TrueView. Also, I think Recap from Autodesk has such an option. And if you want to go into open source, we will talk about PO3, and for the Mac users, we will talk about Entwine. So these are the things we are going to discuss today. PO3 is actually developed by an Austrian researcher, Mr. Schutz, from the Technical University of Vienna. I did my internship a couple of years ago in Vienna, a wonderful city and a very impressive university, but unfortunately I've not met this guy. But he did this within the framework of his PhD, and all the code is open source. So that's a very big advantage. You can just take the code and use the code using the open source license. If you go to the website that I presented here, so po3.org, you will enter a page like this. I don't know if it has been updated in the meanwhile. But what you can find here is, of course, some general information. So PO3 is a free open source WebGL-based point cloud renderer, etc., etc., etc. And you will find some very interesting examples on the same page. So let me go to this website. PO3.org. Redirected to GitHub apparently. I hope that voila, it's just transported to GitHub, so you're being redirected. But here you can find some very interesting examples that are clickable. So if you click, for example, on this one, normally you are redirected to a point cloud viewer. So this is a point cloud that you see here, where you can just rotate the point cloud and have access to some interesting tools. So increase the number of points, do some measurements, make profiles, etc., etc. Or another example, if you want to work with point cloud embedded using airborne laser scan data with some georeferenced viewer in this case. These topics are all possible. And the interesting thing about this is that it's quite easy, even for a non-informatician like me. So just a matter of experimenting with it, and you're able to make data like this or viewers like this yourself. For example, if I go to my website, so geo.hoogem.be, if you have worked on the exercise, we go here to Navplio 3D. If you have worked on the exercise of yesterday, you've seen the Navplio data. And actually the Navplio data is partially visualized here in the same PO3 viewer as well, where you can just access the point cloud In this case, for performance reasons, the point cloud has been reduced, but you get the idea. So if you're familiar with NavPO, we're actually looking at the tree-admiral square in this case. We have the syntagma square here, and normally, if there was no corona, we would have the summer school somewhere here. But now we are, of course, in an online environment. But it's actually, like I said, it's quite straightforward and not very complicated to make something like this. And I would like to guide you step by step for the construction of a point cloud like this. Also, if you want to know more about this, this WebGL-based point cloud renderer, you can always have a look at the dissertation that can also be found online. So some general background about PO3, it's based on Scanopy, desktop cloud viewer also from the Technical University of Vienna. So a more general point cloud viewer like Cloud Compare, for example. And it's totally free and open source, available on GitHub. So you can just download it. And there are some pre-compiled installers available for Windows users. So if you're a Windows user, you can just take the executable, as what we will do in just a few moments. And you will be able to work with this package yourself. What's actually happening here, and what makes it so incredibly interesting, if you have a website that is hosted somewhere, what is happening, you type in the URL, you're requesting a page, and the page is being sent to your browser and being rendered with all the images and patati patata what's in the website itself. So that's quite straightforward and very easy as long as the data sets are quite limited. But imagine the situation that you have a point cloud of 250 megabytes of points or 1 gigabyte of points. If you press or if you type in that URL, and you will have to start downloading the entire data set before you can visualize that, that's not very convenient, of course. So what's happening here? It's actually before you you put your point cloud in that viewer, it's actually making an octree. So this is what you see here. You have a point cloud. It's making cubes. It's putting your entire point cloud in cubes. And based on what you see in your browser, it's actually only downloading, requesting the data that is inside that cube up to a certain maximum number of points. So it's optimizing your data. It's making cubes of your data, octree-based rendering behind it. And by doing that, if you zoom in, you're just forgetting about the points that were already in your viewer. You can zoom in and it will only download the small portion of the point cloud that is being requested. And by doing that, instead of downloading the entire point cloud, these gigabytes and gigabytes of data at once, you can just download a small portion of the data set. And this becomes very handy if you go, for example, here. So this is Entwine, so that's something that we will use with Mac. But I found here, for example, a point cloud of the Netherlands. The Netherlands is not such a big country, as you know, or as you might not know. But this data set that I'm hopefully going to show you should contain quite a large amount of data, but it doesn't. Yeah, it does, voila. So as you can see here, I'm looking at the Netherlands, and it's just loading tile per tile the point cloud. You can actually zoom in. Let me go to Amsterdam. Amsterdam, right here. If I zoom in on Amsterdam, you see that the number of points is increasing. If I zoom in a little bit more, it will just download the data that is requested in this case. For one reason or another, my internet is not very fast today, but you see that it is downloading now all the points that are within my screen. And voila, there it comes. You see here already the rivers in the city. Zoom in a little bit more. Voilà. So that's a little bit of the idea. You have billions of points in this entire data set. And in this case, you're only downloading a small portion of it based on this ID of Octree. So you're actually dividing your point cloud into small portions, and you're only downloading the portions that are relevant for your viewer. So it means, in this case, we're using WebGL and Three.js. So these are just open standards, JavaScript standards that are implemented also in HTML5. So very convenient to use. We will not go into too much detail about JavaScript. But it also means, given the fact that we're using standard libraries, that we don't need any plugins. So the age of Adobe, what's the name? Adobe Flash. These times are over that you need to install a plugin. It's totally plugin free, and that's a very big advantage for using these types of applications. It works on Chrome, Safari, Firefox, on desktop PCs, and even if I would take my cell phone, and I have my cell phone, voila, here's my cell phone. If I would go to the website, I can even visualize these point clouds on my cell phone. So imagine the situation where you have a point cloud of an archaeological site, for example. You go into, in your phone, go to the point cloud of that site, and using these annotations that you already saw here in this point cloud, for example, you can just click on a point, get some information about it, and see the entire geometrical representation. This is, of course, a very interesting feature for presenting your work. For the people that are still using Internet Explorer, bad news, it's not optimized for Internet Explorer 11. But to be honest, I'm not using it myself anymore. If I use it, it's just because I need something with a plugin. I'm a Chrome user. Even on my Mac, I'm a happy user of Chrome. It's client-side application, so the server only hosts the data, but it does not execute any code. So it means that you're actually downloading your data, and all the rendering is all based on JavaScript, and it's all done by the client itself. So it's very straightforward, very convenient. And once again, it does not load the entire point cloud, only the visible regions. So here are some examples from the website itself. So the Sagrada de Familia, here an underwater construction line that you see quite often in this case. And this is also very interesting. This is a point cloud that I generated myself a couple of years ago. It's actually the first time that I flew with my own drone in the archaeological site of Torikos near Athens, in Lavrio, for the Greek people, most you, or for the people that are familiar with that. It's a project under supervision of the effort of Attica and the Belgium School of Archaeology, if I'm not mistaken, and if I use these affiliations correctly. But what you actually see here is the system of levels of detail. So if you load the page, and if you don't have a very small internet connection like the connection that I'm running at the moment, at the first instance, you will see something like this. So just a very rough point cloud. It's a quite dense point cloud that you would see normally. But if you wait a little bit, or if you zoom in, you will see the number of points increasing just as a function of what's being downloaded. And actually, if I go back here, and maybe it may be a little bit more convenient just to take not an entwine, but a normal point cloud. Let me take this one, for example, re-render it. If I go here, so I'm now in Chrome. If I refresh this page, you will see what I'm talking about. So you see that it's just all these small PIN files. These are the files that are being downloaded. So now I'm downloading new files for rendering my my screen, my point clouds. And if I go back a little bit, or go in this direction, you see that I'm just continuously downloading very small files, and that I'm continuously rendering my point cloud. So that's actually the way that it works. And then the challenge now is, of course, how to make these small files, which is obviously done automatically using a tool that I'm going to show you. With PO3, we have the ability also to use different materials. So of course we can visualize just the simple geometry of our point clouds using a white point cloud with a shader on top of it, for example. But also we can use RGB values, so color the point clouds as a function of the coloring that has been acquired with the point cloud, or the color that has been draped on the point cloud itself. Intensity values, classification values, all these parameters can be used for visualization. Point rendering, once again, a point is just a 0D object in a 3D space, so it has no, initially it has no relation to other points. As soon as you give that 0D object a certain volume, you make it a square or you make it a sphere, or you interpolate between these points, you can get a better understanding of the points in terms of relations between points in your point cloud. And you can also play with these parameters in the PO3 viewer. And then some interesting features here, the ability to measure distances. So you can use distance measurements tools. You can calculate areas, make height profiles. So here a height profile through the theater going from here to here, and you can actually see the difference in elevation through your 3D in your 3D model. And an interesting feature here as well is the ability that if you are in your viewer and if you allow the end user of your 3D visualization to do so, that you can also allow them to export a profile, in this case as a comma separated file or as a point cloud. So just point cloud extraction from profiles. That's also possible in this case. This is also quite a cool feature. I already showed you very briefly, but the ability not only just to use PO3 for point cloud visualization, but also to connect these visualizations with geographical information. And this is very interesting if you have your point clouds georeferenced, of course. In this case, I didn't implement it. Go to, voila, to my point clouds. So the big advantage of it, if you go here to a point cloud of the archaeological site of Eleusis, for example, these data are georeferenced. So you can click here on this little map, and then you will get an overview of the user. If I rotate my screen, I can actually see here on the map what I'm looking at. So it might be a very interesting thing, the combination of point cloud visualization and mapping. I think, but I'm not very sure about it yet. No, it is possible, of course. You can also, but once again, I've not implemented yet. But you can also use your own maps for this visualization. So if you're very much into GIS and you're familiar with some web-based services, you can actually connect this viewer with your own map service, demonstrating a map or showing a map of an archaeological site, for example, and then you can make the relation between the point cloud and the map, potentially even with annotations in the map. So it has some interesting potential here as well. The ability to work with variable point sizes. If you are very much into web development, you can also implement additional features from 3GS in the viewer itself. So since it's open source, you can access the code. 3GS is also open source, so you can actually combine those two and add additional layers on the current software. And for the conversion of your point clouds, the LAS files, for example, in our case, you will need a free converter. So it's a converter that is compiled for Windows. So all the Windows users will be very happy. But once again, I will also show you how it works on a Mac or something similar on a Mac. And this converter, it's actually converting your LAS file, so your massive point cloud, to a binary version of the same point cloud where all these tiny little BIN files are generated. The octree is calculated, and then the octree is filled with the points in your point cloud. So that's actually allowing you to have access to this point clouds via your browser. This is not just a software that is used only for academics. It's also implemented for let's say, professional commercial applications or governmental applications like city modeling, for example. Here, an example of a point cloud from Norconsult. Facility management. So if you have a point cloud of an industrial facility, for example, which is a very common application for laser scanning, you can use the different annotations as a reference to spatial databases or database management systems, not necessarily spatial, but also just real-time databases giving you information about the maintenance, about the state of a certain object in your facility. But also, it is of course possible if you have a point cloud of your archaeological site, for example, to use the same annotations or the same references to archaeological database management systems. Road inventories, like the implementation of mobile mapping vans that will require huge amounts of point clouds. These data are stored obviously on massive servers, but you also need ways to visualize these massive point clouds. And here a Japanese application on the use of PO3, another one in Germany. And if we are also, since we also talked about facility management, you can also use the software for city management. So if you have smart city environments where you say, okay, I have my city geometry as a background, and on top of that, I will drape or I will project all my city facilities, like in this application in Finland with the light poles, the traffic lights, etc., etc. And of course, back to the core business, heritage documentation. So a very convenient way of visualizing your cultural heritage that has been acquired either by laser scanning, but also with photogrammetry and image-based 3D modeling. So if you have generated a point cloud in Archisoft, for example, you can also export that point, as we discussed last week, using the export functionality of Archisoft Metashape, and the resulting LAS files can be used as a starting point for PO3. And that's actually something that you will do in the exercise as well. So, for example, here this application of the inner city of the historical city center of Nafplio. And actually, the only thing that I did here was just converting my point cloud to this optimized binary file format. I made a new logo, or I implemented the logo of Heritage, and I put everything online, and that's it. So it was maybe just a few hours of converting and then a few minutes of uploading the data to my server. So let's give it a try. By the way, do you have any questions so far? Wonderful. I'm going quite fast, so I don't think that we'll need the full 2 hours for the demonstration itself. But please, if I'm going too fast or if I'm unclear on one or on a certain topic, feel free to interrupt me wherever you like. So the idea here is to convert a point cloud of the Venetian wall in Nafplio. So let me go to that point cloud. It's actually here in the ts_8_demo_data folder. And in that demo folder, you will find a point cloud that has been acquired in 2018 of the Venetian wall in Nafplio. It's not such a big point cloud, 1.7 million points. So this is actually what we are going to visualize in our browser. This is, by the way, image-based 3D modeling. If you're talking about, I'm actually looking at the back of the wall. This is the front of my wall with some interesting things that you can identify. Use a shader. And go back to RGB. So in any case, this is what we are going to visualize in our browser today. For your information, I also presented the processing reports of the same wall, where you will have some information about the camera used and the processing parameters that are used. That's of course only for your own information. So the thing that we're going to do, once again, this will only work in a Windows environment. I will skip to my PC after this demo to my Mac, and I will show you how to use it in Mac. So we will use this converter, this executable PO3 converter, to convert the LAS file to an optimized Octree-based point cloud, or a series of little point clouds, and then we will use a local web viewer. So we will make a local host first, a local web service, and then we will access the data using that local server. So here's some information about the point cloud, and then we can get started. So I will just follow the procedure that is presented here in this presentation. If I'm going too fast, or in case you want to follow me, let me put it like this. If you want to follow me and I'm going too fast, please ask me to go back a few steps, so that you can all follow on with me. So what I'm going to do, I have my data saved here in this location. In this location, I have this this web viewer. So this is just the data that is put on in the data repository. This is my web server that I will explain just in a few slides. And here you will find the converter with some additional files that are required for the conversion itself. And in the same folder, I also have here my my point cloud. So actually, I can just delete this one anyway. So I have my executable here for the conversion, and I have some additional files, and I have my point cloud. What I'm going to do now is I'm going to copy the path of this location, and then I'm going to my command line. So I go to Windows, I press Windows, and I press CMD, or command line, or command prompt, or opdracht prompt if you're using a Dutch computer, and you press enter. Is there any of you who is definitely not familiar with the command prompt?
Depends what you mean, not familiar.
Are you familiar with, like, for example, just, for example, is this something that looks strange to you?
No, to me not.
To me, yes, actually.
Okay. So the thing that you see here in your command line, or sorry, in your file explorer. Oh, there was a chat. There was a chat. Okay. The thing that you see here in your file explorer is actually just an interface on top of your file management. So your files are saved on your computer somewhere, on your hard drive. And this interface that you see here, it's called the File Explorer in Windows, and it's called Finder in Mac. Just a little moment. Anne, wat ben je aan het doen? Okay, it's called Finder in Mac. These are just interfaces for your file management. What you see here is actually a tool to access your files and to do some things with your files and with your entire operating system, but without a graphic user interface, but with some, it's all text-based. So you're making scripts, or you're adding scripts. For example, now, as soon as I start my, my command line, I'm in this folder. And if I go to this folder on my browser, in my file explorer, let me go there to users. now I'm actually in the same folder. And what you can do then is you can type in, for example, dir. If I press enter, you will see a list of all the files and folders in this current folder. So in the folder that I'm in at the moment. And of course, this list corresponds with the list of files that you see right here. The first thing we have to do is we need to go with our command line to this folder. To the folder d blah, 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 blah. Or in your case, it may have another name, of course. So what I do, first I go to my D drive, my D drive. So I press in D double dot. And then I can simply copy this, the address of my folder, and I can paste it here. So cd space and then the full folder location of the place where my files are stored. Voila, and if I do the same now, if I type in dir, then you will see loszip.dll, po3 converter.exe, blah, 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 blah. And these are exactly the same files as the files that you will find here. So we're now in exactly the same folder. And that is actually what I'm showing you here. So that's identical. Voila. Just a little moment, there's going something horribly wrong. Is alles in orde, Ella? Ella?
Er staan 2 potjes en ik weet niet waarvoor die potjes dienen.
Ja, there's a little technical problem here. Maar meisje, maar er is er eentje voor jou en eentje voor Anne.
Anne heeft allebei opgegeten dan.
Goed hoor. Mag ik een van die potjes? Maar dan moet je toch niet huilen, meisje? Nee, kom eens hier met een potje. Ik zal er wel snoep in doen.
Ik probeer het en het is niet junior. Maar ik weet niet wat dat voor zender is en die is de televisie helemaal rauw gevallen en ik weet niet dan wat ik moet doen. Dus ik heb gezet helemaal uit.
Zo.
Zeker weet alsjeblieft een eitje.
Nee, ik ga een eitje. Zo, kijk eens aan. Hopla. Alsjeblieft.
Ik heb het niet.
Hier, dan heb je weg. Just a little moment.
Ik heb die ook niet.
Mm-hmm.
Oh, sorry, I didn't know. Thank you very much.
I'm very sorry for the delay, but my oldest daughter was crying because of some difficulty here. I hope you would excuse me for that. So anyway, are you still there?
Yes.
Yes.
Okay.
No, we went there.
Once again, sorry for the difficulties, but I'm running the household at the moment myself. Nee, het is... Ga maar ja, ga eens gewoon op de bank zitten dan.
If you need the break for 5 minutes, it's fine with me.
Yeah, but I'm a little bit afraid that they will need more time than that. kindly requested them to sit in the living room. And we are going to do that. We gaan netjes in de woonkamer zitten. Voilà. So at the moment I am in the same folder here. So I typed in, I went to my partition, I copy pasted my my folder name, I checked the content of the folder, and I'm sure that I'm now in the same folder as the folder that I'm here, the PO tree. I also see my executable here, and I see my LES file here. Voila, and we're back on track. We're back on track. So in order to run this program, what you would normally do when you're not familiar with a command line, you will just go here and double click it. And what you will see then is, first of all, a protection, blah, blah, blah. Let's run it anyway. You will see something flashing up and it will disappear again. So I can just do it again and nothing will happen. It's just and it's gone. The reason why it does that is that we have no interface on this program, and we actually have to give the commands not by using a graphical interface, but by typing in all these commands. And the most straightforward thing to do here is not double clicking it because nothing will happen. But what we can do is just type in PO3 converter. And if we press enter, you will see this. Let me enlarge it a little bit. We will see this. So the thing that you saw while flashing up, if you can read very fast, if you have super fast eyes, the thing that you saw here is actually exactly the same as the thing that you will see here. And this is actually just the help that will assist us on preparing our program. So what's happening? We run a program, and next to that program, we have to give the program some attributes on processing the data, on setting a web page, on fine-tuning, setting some geometrical parameters of the processing, etc., etc. So let's put this here, and let me go back to my presentation and put it here, that you can clearly see the synergy between the two files. So what I actually did now is I have PO3, and the first thing I can do, for example, is just say -h. So PO3 will run, and it will have one parameter, -h, and -h is the thing that you will see here, print usage. Actually, it's just the same as what you will see if you don't give any parameters. So this will give us the help, and we will use this help functionality to process our data. So let me go here. Among others, we have some very important parameters here. And the most important one is, of course, the first one here, this -i or minus source. So what you see here in squared brackets is the same as what you will type in if you just have one -i, and that's the input file. So we need to give an input file. Well, apparently this version has a little mistake, because in this case we don't have to use this I, we just type in the input file. We can make, using this P parameter, it will make a ready-to-use web page with a given name. So we will use that option just to make a ready-to-use HTML page. Optionally, you can also say, okay, I don't want to save it in the current folder. So in this ts_08_demo_data, blah, 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 blah. But I want to save it in my files, or I want to save it on my server page, or I want to save it anywhere. Doesn't matter that much. You can set your diagonal spacing. So that's the D parameter that you will find here, the maximum number of points on the diagonal of the first level. So it sets the spacing, the diagonal divided by the value. So that's something that you can use to optimize your visualization. The number of levels. So if I go to my first level, let's say that if I just press Ctrl R, let's say that this is my first level. If I zoom in to my highest accuracy, not too much. So let's say that this is my highest point cloud resolution. How many levels, so how many dividing levels should be considered here? It will calculate that automatically, but if you want to overrule that automatically calculated value, that is possible using this, this L value. And if you want, you can give your page also a name instead of working with some kind of a stupid blah blah name. The title that you see here, title, and then the variable that you will give with it is actually the name that you will see. I have too many pages here. So let me close some files. I hope I didn't close anything important. The title of the page is actually what you will see here. So in this case, for this page, I had title is 5.0 space CN space regular space point space cloud. That was the variable that I gave here for my title. Very important, by the way, if you want to use spaces in your title, you have to use double quotes. So that's also something to keep in mind. And then we can actually get started. So what we can do now, just for example, is say, okay, let's go here, PO tree converter. Let's have it here. So PO tree converter, we're still in that folder. We need the name of the file. If I'm not sure what the name was, I can just go back here, dir. And what was my name? It was Venetian_wall_navplio.las. So that's me say Venetian_wall_navplio.las. I want to make a page. So that's this P parameter. Here, generate page. And this page comes with a title. So I will give it a title. Wall, for example. Or wall underscore navplio. I can also give it a title. Venetian wall at navplio, for example. Actually, these double quotes here are not necessary, but the quotes that I typed in here for the title, because of the fact that I'm using spaces, in that case, my double quotes are definitely required. So please keep that in mind. And now we can press enter. And if I didn't make any typos in this command, it is now converting using PO tree converter, the dataset Venetian wall.las. And it's not only converting it, but it's also making a page and it's giving the page a title. So what you see here now, hopefully, is that it calculated some, or it extracted some metadata. So we have the title, we have a default folder name here. We have some diagonals calculated. We have a title page. The minimum, maximum, some statistics on the dimensions, and apparently I have less than 2 million point cloud, so it's now optimized and we are already ready. So for 1.7 million points, it goes very fast. What you see now, so if we go here to my file browser, you will see that a new folder has been generated. The folder is entitled here Venetian wall_navplio_las .les underscore converted. So this is just the name of my original point cloud, and it has an underscore converted on it. If I go to that folder, you will indeed see a folder with point clouds. So these are, if you go in here, in this case, you will find all these different BIN files. These BIN files are all indexed. So there's an indexation behind it that is defining the volumes and the dimensions and the geometry and the configuration of these octree. And of course, and that's very interesting for us, we have here an HTML page that we will use for accessing our point cloud. So this is actually the file referring to the ability to access the data set. Anne, ga eens van die bank af. if we open our file, so if we open our HTML page, then normally this is what you see. If this is the case, don't worry too much. I can also open here my console using Command-Shift-I, and I will see a lot of errors, a lot of errors. Voila. So my browser in this case is not able to visualize my point cloud. And if you remember from the previous module, when we use this 3D visualization, browser-based 3D visualization, this has to do with the security parameters of the browser itself. So we cannot just open an HTML page using our browser, but we have to use a server in this case. So this will definitely not work. And that's actually what we also did a couple of weeks ago. Voila, here. Different options to start a local host, so a local server, and from that local host you will be able to access your web page. I give you various options here, and once again these options hold for Windows users. I have an additional option for Mac users. So the Mac users that joined me last week, they know that it is possible to make a local host using Python, but apparently that does not work with PO3. We have to use an additional script, but I will go into a little bit more detail on that after the break. So in the Moodle platform, you will find two scripts, a Python 1 and a Python 3 file, or you can just load your mini web application, the same mini web application as what you already found in the previous summer school or the previous program. So here, optional procedure for running the Python script. So it's just simple Python space and then the name of that file, and your local host will run. But I think in your case, it's much more convenient to run this program that you will find here, the MiniWeb. If you run this program, you will get a message for your firewall, so we can allow the local host to run and get an exception through our firewall. And what's happening now, if we go to our local host, so if we go to the local host on, not on 8080, but on 8000, we will actually see this. So if you see this, then you know that the local host is working properly. What you see here is actually the same, or the same amount of data as what you will see here in this folder. So in the data folder, you will find the folder htdocs, which is empty. And this is actually the same content as the content that you will see here. So in order to access our web page, only thing you will have to do, and that's the last thing I will bother you about here in this for the construction, Anne gaat van die bank af, is just copy this page that we just converted, including the data, including all the lib folder and the HTML page, and we paste it here in our htdocs folder. And if you go back to our browser and we refresh our page, you will see that indeed this folder has been included in the file here. So I can access it. I can open my HTML page. And now you see here, so that's a very important difference. If I open, just by double clicking this HTML page, you will see here the path referring to the project, summer school, laser scanning, blah, 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 etc., etc., etc. Whereas in this case, we are actually running our viewer via our local host. So we have our local host, and from that local host, we have a reference to our point cloud. And that is actually what we're seeing here. This is just the point cloud itself and the access to that point cloud. And from here, we can use point measurements. So get the coordinates of a point. We can do distance measurements. Measure from here to here. Apparently it's almost 4 meters. And stuff like that. So that's actually the finality of this entire process. if you're using not only, because the problem that you will have here, or the difficulty that you will have here is that this local host, in my case, my local host is of course only accessible for me on my computer. So nobody in the world has access to that local host unless I give them my IP address, but that's something beyond the scope of this lecture. But if you want to make your point cloud accessible, what you will actually have to do is go to your server and then just simply copy paste this data set, copy it and paste it to your file server, to your FTP server or something like that. If there is a web service behind it, like Apache, people can access your point cloud by just typing in the URL, including here, in this case, wal_navio.html or index, for example. So if I make this index and I go here to the folder, I will also have access to the same point cloud. Not anymore, because I should not change the name. So that's not fully true. So let me revert that. Voila, and then I copy it, and then I have access to my point cloud. So I think, although maybe I'm going a little bit fast over this material, but I think that if you start experimenting with PO3, and if you start making yourself familiar with the command line and the use of the command line for converting files, and actually it's quite straightforward. You can actually just copy paste this as long as you're in the same folder here. Modify your parameters. This is a very easy way to play with these kinds of coding. So that's quite straightforward for converting your point clouds and also making your own websites with the point clouds incorporated in it. If you are really working with extremely large point clouds, like point clouds that have several hundreds of millions of points or billions of points, I would not recommend to use PO3. It is very powerful. PO3 is very powerful, but I would use an even more optimized library for that is built on top of PO3, and that's Entwine. And actually Entwine also allowed me to make this demo operational on a MacBook. So here is the page, and I also already showed you the Dutch elevation model using Entwine. So voila, that was what I wanted to show to you.
Ik heb nu gedaan en een ander boek.
Helemaal goed.
Mag ik nog een beetje?
Do you have any questions so far?
Nope.
Perfect. I think I will need like 15 minutes to show the same on my MacBook. There are MacBook users, amongst you?
Yes.
Yes.
Okay. Yeah, 2 confirmations. In order not to let you wait, I would propose just to continue, if you're fine with that, so that we skip the break. I will just... Anne, ga eens eventjes terug met de woonkamer, alsjeblieft. Kom op. Nee, je mag eventjes niet zeuren. So I will... if you're fine with that, I will skip the break and I will show the same procedure on my Mac. And then we're actually done. And after demonstrating it on my Mac, I will need a little break, and we can use the time that's left for some questions and answers. If you're really happy with it, and if you're not interested in the implementation of this procedure on a MacBook, or if you don't have any questions, or if you don't want to participate in the question and answer session, just some information about tomorrow. So normally Michele Coruni will give a presentation about a very interesting application of laser scanning in an underground system in Bologna. So he will give a talk about that. And afterward, we have a closing word from the director of Heritage, Professor Kyriakidis. And then yeah, we have some additional time also for question and answering, also maybe a little discussion about the general exercise. So that's the plan for tomorrow. So if you don't want to participate in the question and answer session, feel free to leave this session. I will now go to my other laptop and actually do that instantly, make myself host to demonstrate the same procedure on a Mac. Then we will have a little break of a few minutes and have a little discussion and question and answering session, if you're fine with that.
Yeah, perfect.
So make myself a host. I'm the host now. Voila, there I am. This is very strange to see me on two screens here. I will stop this video now. You can still hear me, eh? I hope.
Yes.
Ah, perfect. Thank you. Then let me share my screen. Voila. As I can see it here, it's also working. So the problem is that if you go to the website of PO3, you will find a converter, and this converter is only accessible or only usable for Windows users. So it's just a normal executable, very straightforward for Windows, but not for Unix systems like Linux or Mac. So I'm not an informatician. So first of all, I was very enthusiastic and say, okay, I'm going to compile the code myself. But fortunately, the thing that is available for Mac and is very straightforward to install is actually this thing here. If you go to Anaconda Entwine, then this is the module that you can follow for Mac users. And actually, if I'm very honest, the same holds also for Windows users, but I think that the converter and the data management of PO3 is a little bit more straightforward. So in the WhatsApp group, I ask you to install Miniconda. So Miniconda is actually some kind of an environment on top of your normal Mac environment that will manage some libraries. It will give you access if you're familiar maybe with Python or R. I don't know if you are familiar with that. But if you are, Anaconda is a very straightforward way to manage your different packages and dependencies and stuff like that. And if you are in Anaconda, so I'm having it, let me go here. What I actually did is say, okay, I have Miniconda installed, or Anaconda installed here. And then it's just a matter of copying this. So Conda creates an environment. I'm going to make a new environment. I'm going to access that environment. If you really want to know more, if you're interested, I can maybe just type some kind of a little manual on what to type and when to type it. But I actually just followed this quick start page. So after having Miniconda installed, I created an environment. I accessed the environment. That is something that I can show you. Let me close this. Here's my console. Conda source activate Entwine. Voila. So now I'm in the Entwine environment. And what you can do then is in my demo folder here, let me just remove the Elysys folder because I don't want to cheat in this case. What you can do then is, let me put it in a more convenient folder. For example, in my the root. Voila, the demo data is now in the root of my folder. LS from laser scanning. So I can go to ls ctls. And ls contains 3 files. So actually, this is just the same as what you would find in the command line in Windows. And then you will still have these this LAS file. So in this case, I will demonstrate it using the terrestrial laser scanning data of Elysys. You can just open it. Now, lab. Let me open it. I think this is, by the way, the first time that I'm opening Cloud Compare on my MacBook. So a historical moment for me. As you can see, I get a lot of exception requests, blah, blah, blah. And I will open it as LAS file. Voila. So here in this case, I will visualize 26,300,000 blah, blah, blah points in my point cloud. Actually, just this point cloud. Luckily enough, this is not a, this is a live demo, but everything that I'm going to show you has been tested just an hour and a half before this moment. So this is what we're going to visualize in the browser. In order to do that, it's a little bit more simple. You can just use this script here. So in this case, we're going to use the Entwine module. If we type in Entwine and we press enter, Entwine, it will give me some kind of an error message or a help message, hopefully. Hello? No. Entwine H. No. So I will just use Entwine build as mentioned here in the quick start manual. My input file in this case is located at ls and it's called Elysys.las. And my output file, I have to define my output file here. And my output file, so -o, I will also call it Elysys. And I think it will give me an error because Elysys cannot be found. Invalid path. So I have to define it as a function of the root, which is install ls. And here as well, I will also give the path related to the roof. That should no points found. Elysys.las. TLS.las, I'm sorry. TLS_Elysys. Of course, I have to do it here with my paths. File not found. You see, I'm not that familiar with Mac. Yeah, voila, now it's finally working. So what I did here just summarize it a little bit. I'm using Entwine. From that Entwine thing, I'm using the build module, so the conversion tool that will convert my LaserScan point cloud, my LAS point cloud, to this Octree-based system. And I'm referring to an inp file. This is my input with the absolute path, or the path referring to the related to the root of my system. And I'm also defining an output location. And the output location, instead of making a web page, it will just make in this case a JavaScript file or JSON file defining the Octree itself. So this might take a little bit longer than the 1.6 million point cloud that we already have, because in this case we had, how much was it? 26 million points. So now my Mac is blowing, but we're already done. It's all as good as done. Voila. So it did actually the same. It extracted some metadata. It extracted some dimensions of the box. It converted my point cloud into smaller boxes. It extracted the coloring information. And the result of that, if I go back here to my LS folder, is a new file here, or new folder, where I have my data. Unfortunately, I don't have an HTML page, so it is not very easy now, or it is a little bit more difficult, let's say, to visualize these point clouds. But fortunately, there's an option for that. What we can do here is go to viewing the data. So this is actually something that you can do. And in this case, you have two options. Either you say, okay, I'm going to use Conda to install a local server, and then everything is fine. So you can just do this Node.js, install your own server, and then access the server. I decided not to do that. So what I did is I have here a Python file, and the same Python file is also accessible via on the Moodle platform. So since we are still in the correct folder here, to LS, and you see here the same Python file, what you can simply do now is say Python simple course.py. And now we're also running a local host. If I would go to my local host now, localhost 8000, it will of course give me an error because I don't have any data available here. So what I can do then is go to Eleusis. Voila, and here are my my data. Once again, it has not generated an HTML page, so it's not very straightforward as for Windows users, where you just click, okay, I go to this HTML page, blah, blah, blah. But on the help, there is a solution for that. On the quick start. Let me go to quick start here. And what you can do is just type here, for example, just let's access PO3 view. And what it will do, it will get the HTML page from a main server somewhere. So this is just the main viewer. And as an attribute, it will use your local host in this case. So the only thing I have to do is set this file correctly, 8000, and here type in Eleusis. And here's my point cloud in Mac. Not very straightforward compared to Windows, but at least I can offer you something that has the same finality.